Humans are obsessed with time. We wear watches on our wrists, hang clocks on our walls, use candles and fireworks to mark the passage of time, and we also use it in a lot of everyday phrases, such as time flies when you're having fun, time waits for no one, time will tell, and time will mend a broken heart. We quite often wish we had more time. But what really is time, and how would you explain it to somebody? Time remains one of life's greatest mysteries, and one that physicists are constantly trying to learn more about. With that in mind, here are 10 things you should know about time. 1. Our time is based on the Earth, but the Earth is terrible at keeping time. Our ancestors broke up their days into manageable chunks of 24 hours because that is how long it took the Earth to complete one spin. A month is based on how long it takes the moon to go through one complete cycle of its phases, and these were originally called moons. However, the spin of the Earth does not always move at the same speed, meaning a day is not always 24 hours long. The moon has a pull of gravity on the Earth, and the Earth slows down as it tries to move through this pull of gravity, meaning a day is actually slightly longer than 24 hours. This only affects time by a fraction of a second. However, over a long period, that can make a huge difference. Around 430 million years ago, a day was only 21 hours long, and there were 420 sunrises in a year, meaning a year was really 420 days. These days, we use atomic clocks rather than basing everything off of the Earth's time. But even these two ways of keeping time need to be adjusted so they can line up with each other. We say that a year is 365 days, which is how long it takes the Earth to orbit round the Sun. However, it actually takes the Earth 365.25 days to orbit the Sun, and that is why every 4 years we add in a leap day so that our atomic clocks continue to match up in line with the time it takes the Earth to orbit the Sun. 2. Radioactivity can be used as clocks by scientists studying the past. When archaeologists dig up the remains of a living thing, such as a bone from a human, one of the most important parts of their job is finding out how old their discovery is. The first recognised writing system was only devised around 5,000 years ago. So how do you find out how old something is if it wasn't written about? To do this, they use the radioactivity of their discovery. Atoms make up everything around us that we can see. Living things absorb carbon-14 atoms, among other things, from the environment. Over time, carbon-14 decays into nitrogen-14, and when a living thing dies, it can't absorb any more carbon-14. So by knowing how long it takes carbon-14 to decay into nitrogen-14, and by looking at how much carbon-14 is found in their discovery, archaeologists are able to age their find. This is called radiocarbon dating. However, radiocarbon dating is only accurate up to around 50,000 years. So how do paleontologists studying fossils and geologists studying the age of the Earth manage to find out ages that are much older than 50,000 years? Well, to do this, they use the radioactivity of the rocks, which are also made up of different types of atoms. By looking at how long it takes uranium to decay into lead, potassium to decay into argon, or beryllium to decay into boron, these scientists are able to find out the age of discoveries into the millions and even billions of years using these radioisotopes. 3. We are always seeing the past, never the present. Light is the fastest moving thing in the universe at around 186,000 miles per second. That's fast enough to orbit the Earth 7.5 times in the time it takes your heart to beat once. Although when you flick a switch it might seem that the light reaches your eyes instantly, it has actually taken time to get there. If you're looking at someone standing 3 feet away from you, you're actually seeing how they were 3 billionths of a second ago. It takes the light from the moon about 1.3 seconds to reach the Earth, and it takes light from the sun around 8.5 minutes to reach the Earth. When you move out further into the universe, you're not working in light seconds or light minutes, but you'll hear people talking about light years. Despite what the name suggests, light years actually measure distance rather than time. A light year is the distance that light travels in a year, which is around 5.9 trillion miles. The nearest star to the Earth outside of our solar system is Proxima Centauri at around 4.2 light years away. That's almost 25 trillion miles away. One of the brightest stars in the night sky is Betelgeuse, which is 700 light years away. Astronomers know from studying Betelgeuse that it is approaching the end of its life and will eventually explode in a supernova. The light from this explosion will be so bright that we'll be able to see it during the daytime, and it will also be brighter than the moonlight we receive. However, because we are seeing the light from Betelgeuse 700 years ago, if it exploded 699 years ago, we won't even know about this for another year. 4. Time flies like an arrow, always moving forward. Or to use a witty phrase that somebody once came up with, time flies like an arrow, fruit flies like a banana. We move from one moment to the next. We move from today to tomorrow, not from today to yesterday. And we can remember last week, but we can't remember next week. This is because time is always moving forwards. There are 4 laws of thermodynamics, unbreakable laws which explain how energy and heat operate. In the second law of thermodynamics, it says that systems will always move from order to disorder, which physicists call entropy. Therefore, the arrow of time always moves from a system of low entropy, which means more ordered, to high entropy systems, which means disordered. Imagine you had a brand new deck of playing cards. You open the box, take them out, and they're all in numerical order and all together with the cards of the same suit. So all of the hearts are together, spades, clubs and diamonds. If you were to shuffle this deck of cards, there is a 1 in 10,000 quadrillion chance that you would get them back into that order. That is a 1 with 64 zeros after it. The universe is a lot more complicated than a simple deck of cards. As the universe becomes more and more disordered, there will come a time where there is not enough energy for stars, planets, or even life. But this will not happen for billions of years. Order always leads to disorder, and that is why the arrow of time is always moving forwards. 5. Space and time are 2 sides of the same coin. Although we often think of space and time as different, after all you can choose how and where you move, but we are always stuck with the arrow of time flying forward. Space and time are actually connected as a fabric which makes up our universe, and we refer to this combination as space-time. Einstein's theory of general relativity, some of which I covered in 10 Things You Should Know About Space, explained that mass, the amount of stuff something is made of, bends space, and it is this bending of space which causes gravity. However, if space can be bent, that means that time can also be bent because they are connected as space-time. Einstein's theory said that events which take place in space-time would cause ripples, which physicists call gravitational waves. The experiment LIGO was set up to try and discover these gravitational waves. LIGO involved 2 arms that laser beams were fired down to bounce off a mirror at the other end and come back. And these laser beams, moving at the exact same speed, fired at the exact same time, would hit the mirrors and come back to the start at exactly the same time. However, when a gravitational wave passes through LIGO, the length of one of the arms is affected, meaning that the laser beams actually come back at different times. So not only was the space affected, with the length of the arms being affected, but time was also affected. Einstein's theory has passed every test that has been thrown at it, and it shows that what affects space also affects time. So if we can travel in space, does that mean we can also travel in time? 6. Time dilation means that we are all time travellers. If you were racing world record holder Usain Bolt in the 100 metres, it would be no surprise if he got to the end before you, because he can move in space faster than you can. However, as we've just learned, space and time are connected. So if he can move in space faster than you can, he's also moving in time faster than you. So Usain Bolt actually reaches the future faster than you do. The amount by which he reaches the future is actually really too tiny to be of any notice. Astronauts are our most successful time travellers, as they have travelled faster for longer than any of the rest of us. However, just the steps you take in your life will mean you reach the future 3 nanoseconds faster than if you stayed completely still. Although this might sound quite crazy to you, it has actually been tested and shown to be true. Our GPS system actually relies on this fact. The satellites that we use for our GPS system are flying around the Earth at thousands of miles per hour and are also less affected by Earth's gravity. This means the clocks on the GPS system run differently from the clocks on Earth, and they need to be adjusted to keep the times matching up, otherwise our entire GPS system would be useless. If humans could move fast enough, our time travel could be measured in days, weeks, months, or even years if we got up to high enough speeds. However, there is a catch. I've already said that the arrow of time is always flying forwards, and time dilation does not allow you to go back into the past, so you would need to try and find some other way to return from the future. 7. Your feet are not exactly the same age as your head. This involves another form of time dilation, this time caused by gravity rather than by speed. We learned earlier that gravity bends space, and we also learned with the LIGO experiment that what affects space also affects time. Anything with mass has gravity, and this creates a gravitational well. The deeper into the gravitational well you go, the slower time will move for you. Your feet are deeper into Earth's gravitational well than your head is, so your feet age slower than your head, and taller people move into the future faster than shorter people. On Earth there is such a tiny impact made by the gravitational well that we don't notice. However, if you wanted to travel further in time, you would need to get closer to a stronger gravitational well. An excellent example of this appeared in the film Interstellar, where on a mission to a planet next to a massive black hole, the personal lives of the characters were greatly affected because of how much slower time had moved for them compared to the rest of the universe due to being deep into that gravitational well. 8. It might be possible for time to be stopped. If you were to fall into a black hole feet first, the pull of gravity on your feet would be stronger than the pull of gravity on your head. In point 7, I did say that this is also the case on Earth. However, the difference between the pull on Earth and the pull in a black hole is huge. On Earth, being deeper in the gravitational well with your feet doesn't really affect as much at all. In a black hole, however, this would lead to you getting pulled apart in a process called spaghettification. You would reach the centre of the black hole anywhere from a second to a day after falling in, depending on the size of the black hole. When a large star burns out all of its fuel, it collapses in on itself due to its own pull of gravity. This collapse continues until it creates such a strong gravitational well that not even light can escape from it, and this is what is called a black hole. At the centre of the black hole is a space smaller than an atom known as a singularity. It is thought that within a singularity, time would no longer exist, and neither would you if you'd fallen into the black hole. Many physicists think that a singularity is just a placeholder for something that we don't yet understand. General relativity and quantum mechanics are two theories which don't really mesh very well together, so physicists are constantly trying to come up with a theory that will combine these two and help us explain more things about our universe, such as time being affected in a singularity. Two strong contenders for this theory are string theory and loop quantum gravity, and I looked at loop quantum gravity in more detail in my video 10 Things You Should Know About Physics. 9. Physicists have come up with a way to travel back in time. It is called a wormhole. Although wormholes are very popular in science fiction, they do not break the laws of physics, and black holes used to just be part of science fiction, but now we have proof that they actually exist. To picture a wormhole, we're going to start with a sheet of paper to represent space-time, with Earth at one side and Proxima Centauri at the other. With our current technology, the fastest way to get from Earth to Proxima Centauri is to travel in a straight line. However, we've already learned that space-time can be bent. So if we fold our sheet of paper in half, now our two destinations are right next to each other. If we then take a sharp pencil and put a hole through the paper between the two destinations, that is what is called a wormhole. If you were to take the Earth end of the wormhole and fly it around at close to the speed of light for 5 Earth years, then only 6 months will have passed inside the wormhole due to the time dilation caused by speed that we looked at earlier. If you then jump into the wormhole, you would be travelling 4.5 years into the past. However, travelling into the past does throw up some complications. One of these is known as the grandfather paradox. In this situation, somebody travels back in time and tries to kill their grandfather. However, if they actually successfully killed their grandfather, that would lead to a timeline in which they were never born, so they'd never be able to go back and kill their grandfather, which makes this whole situation impossible. If somebody was to go back in time and try and kill their grandfather, the laws of physics say that every attempt should fail, otherwise you get a timeline that couldn't possibly exist. Another one of these situations is called the bootstrap paradox. In this example, let's say you had a copy of Einstein's theory of general relativity, and you travel back in time to before he wrote it and ask him to sign your copy. Einstein reads what you hand him, and he decides to steal your idea and publish it as his theory of general relativity. Well, then who actually came up with the theory? It can't be you, because you took Einstein's book back to the past. But it can't be Einstein, because he stole the idea from you. And this is what makes travel in the past really tricky. 10. Everything that ever has or ever will happen in the universe is out there somewhere. The Big Bang created space and time, and there is no process which can create more space-time. When you drive down a road, the bit of road in front of you doesn't just suddenly appear once you reach it, just like the bit of road behind you doesn't just suddenly disappear once you've gone past it. With all we've learned about the connection between space and time, why should time be any different? This means that tomorrow already exists because it can't be created, and yesterday still exists because it can't just suddenly disappear. We don't say Mars doesn't exist just because we're on Earth, so we shouldn't say that tomorrow doesn't exist just because we are in today. Everything that ever has or ever will happen in the universe is out there. Somewhere out there you are being born, and somewhere else you are eating last night's dinner. Another way to think of this is time being like a book. From any point in the book, the past and the future already exist. You can't change when the events of the book are going to happen, you can't move them from one page to another. And in fact, when the book is closed, it doesn't mean that the words inside the book don't exist. Everything that happens in the book and when it happens is already there and written in place. You can't change any of it, and that is why you can't go back in the past and kill your grandfather, as we looked at in the previous point about time travel. 2 things to keep in mind at the end of this video. 1. If everything that is going to happen already exists, that means we're just making our own way through space-time based on how fast we travel. It's just like I was saying with time being like a book. If I read a book faster than you, I will reach the end faster. So if I travel through space-time faster than you, I will reach the end faster than you do. If everything that is going to happen has already happened, that means all of your mistakes and choices have already been made. 2. Even though all of space-time is out there and everything that is going to happen has happened and is out there somewhere, we still only have one life to live, and we've got no idea when that time is going to come to an end. So make the most of the time that you have and enjoy the opportunities that you have to continue to explore and learn more about our universe. Thank you for watching this Things You Should Know video. The majority of the information for this video was taken from 10 Things You Should Know About Time, written by Colin Stewart, as well as some other science reading that I have done. If you liked this video, please hit the like and subscribe buttons to stay up to date on all future content. You can subscribe to the channel by pushing the button here, and I've added a link here to the STEM demonstration and explanation videos I do, and down at the bottom I've added a link to my STEM career interviews and to my other Things You Should Know videos. This has been STEM with Mr. N, looking at 10 things you should know about time.